For a trinomial to be considered as a perfect square, it has to satisfy important conditions. Now, understanding this is very important because as we go to factoring and all other things related to that, the identity of perfect square trinomial will be used from time to time. Now, let's consider this given expression here, a squared x squared plus minus 2abx plus b squared. This is just for the general expression where a and b are both constants and x is our literal coefficients. We can say that it's a perfect square trinomial if the first term is a perfect square. In terms of the numerical coefficient or constants, let's say here a, it should be a perfect square number. Hence, that's why it is expressed as a squared. For our literal coefficient, if present, should be with even exponents. Just like if you have x squared, this is actually a perfect square of x. We have here 25y to the power of 4. We have a numerical coefficient which is a perfect square of 5, that's 25. And since our exponent of y is even, y to the power of 4, it's a perfect square of y squared. This is also true if you have this expression. 4 is a perfect square, m to the power of 6 has an even exponent, and n squared also even exponent. So all of these terms are considered to be perfect square first terms. If this and similar to this can be found on your first term, then that automatically satisfies the first condition. The second condition is on the last term. The same condition for the first term should be followed with the last term. So the numerical coefficient should be a perfect square number, a positive perfect square number, and numerical coefficient if present with even exponents. Now here comes the identification for our middle term. This is very important to settle whether a trinomial is a perfect square or not. The middle term, let's say here in the given expression here, plus minus 2abx is equal to the plus minus twice of the square root of the first term times the square root of the last term. This, if your middle term satisfies this condition, then together with the first conditions for your first term and last term, automatically will have a perfect square trinomial. Okay, so say for example, if we have this expression here, 4d to the power of 4, we're looking for the middle term, and plus 9e squared f to the power of 6. We would like to come up with a perfect square trinomial. Hence, let's see if the first and the last terms satisfies the first condition. 4d to the power of 4 is a perfect square because 4 is a perfect square number and d has even exponent. This is also true with 9e squared f to the power of 6. 9 is a perfect square. E and f both have even exponents. Since we have satisfied that, we can use that in solving for our middle term, which is again plus minus twice the square root of the first term and the square root of the last term. Take note that we're using here plus minus because for a perfect square trinomial, even if it's minus twice or plus twice, as long as it satisfies the condition, it could also generate a perfect square trinomial. So doing this, it's a plus minus 2. Square root of 4 is 2. The square root of d to the power of 4 is simply take a half of it. That's why it's 2. And that's also the reason why the exponent should be even to be called perfect square, so that we could simplify it using radical expressions. For our last term, you have the square root of 9 is a 3. And then the exponent of e is 2, so half of that is 1. And 6 for our f, half of that is 3. Now simply multiply all the necessary coefficients. So that's 12 d squared e f to the power of 3. That should be your middle term, so that 4d to the power of 4 plus minus 12 d squared e f to the f cubed plus 9e squared f6 is a perfect square trinomial. So we have a lot of examples in our channel. Please try to view them so that you could master the identity of perfect square trinomial, because once you do this and you are going to have factoring, there's a specific process in factoring perfect square trinomial. And again, this idea could help you in quadratic equations simply in finding the roots.